There were three features that I asked for you to include on the graphs. What were the three features? Okay, number one, intercepts. Number two, asymptotes. And number three, a point for scale. Okay, now, let me just mention a couple of things about this. I got asked the question, like, what's the difference between sketch and draw or graph or illustrate or whatever verb they have there? My short answer to that question is no difference. They ask you to draw it, you put on as much detail as you can, and in this case, like, these are the important things that you need in order to be able to determine this is the graph that has been asked for, and it's not some other graph that looks similar but might be slightly different. For instance, without being too spoilery, I think you can see that graph 1 and graph 4 are more or less going to have the same shape. They'll have the same intercept, they'll have the same asymptote, right? So if that's all I put on there, you won't be able to tell which graph is which, and that's why we have a point for scale, because that helps you distinguish, okay? So these kinds of it's not an arbitrary list of things that we want you to put on there. These are the things that if you don't have all of them, I don't really know if you can accurately draw this graph, right? So these are the things that will help me understand if you know what you're doing, okay? So let's start doing this. Now, this is just our basic long graph. Okay, now we're familiar with the basic shape of it, okay? But now we need to start putting on the information, okay? So for example, in order, intercept is only 1. There's an x-intercept, which is? 1. Excellent, okay? Just like the y-intercept of the corresponding exponential would also be 1. There's an asymptote. There's always going to be one asymptote. What is it in this case? X is equal to 0. And you should label it as such, okay? Now, I'm almost done. My point for scale here, okay? Now, the easiest way I think you can do this is that, like some students I've seen, they'll say, okay, well that's 1. And so I'll put 1 up here, and then I'll mark it across. Now, that's going to cause you some problems, okay? Because one of the most important things about scale is that your axes can be different to each other, but they can't be different to themselves, right? So, see how I put an intercept on here, right? Now that I've locked that in, this distance on the x-axis, this distance must be 1. It must always be 1 wherever I am on the graph, right? So therefore, the way that I would approach this is I would say I've drawn my curve, right? A nice convenient point, and you really can pick any point you like, right? Pick easy values rather than hard values. An easy one would be 2, right? Because I'm in base 2. If I were in base 3, I'd choose 3, right? Now that that distance is correct, once I map that up to the corresponding point up there, okay, wherever that equals to, I know what that value is going to be. It's log base 2 of 2, which is 1. Okay. Now, as it just so happens, because I'm such an awesome grapher, right, the 1 on the y-axis pretty much matches the 1 on the x-axis, but it doesn't need to. It doesn't need to. It can be much higher. It can be much lower. It doesn't matter as long as this is consistent and I have a point. Okay. Now you do have a choice, by the way. You can see the way that I've illustrated, like I've put that point on there and I've shown the line so you can see where it is. Alternatively, you can mark in, the other way around, 2, 1. That unambiguously tells you where that point is, but seeing as you have to measure from the axis, I kind of figure you're saving yourself time just by doing it the once. Okay, but either is fine. Okay. Now, just before I leave off this very first example, I will mention, okay, in some cases, particularly as you go further into like extension 2 and that kind of thing, sometimes you will be provided axes to draw on, okay? Now, you might think they're trying to give you a hand, and they sort of are, but they're also making things harder for you, because if they provide for you a set of axes, right, almost certainly that set of axes will come pre-packaged with a scale, right? And there will be numbers there that are defined for you, right? Now, once they have defined it, you're locked into using them and you must be consistent with them. And you have to be consistent all the way, right? So not only do I have, this point over here, right, which is the intercept, I'm going to have, for instance, there's 2, 1, okay? But as a marker, once I see this scale, I'm going to look for a third point straight away. Have a look at the scale I've got here. I'm going to go to 4, and that's going to have to match up to 2. Okay. Now, if you do the way I approach it, you just go, whee, you just draw it, right? Almost certainly, you'll draw something like this, which looks like a log graph, doesn't it? But it's not to scale on this set of axes. Okay, so in those cases where you do get given a set of axes, watch out for them. They'll come with numbers and you've got to use them, right? So just plot a few and then just draw your graph a little more carefully.
I'll just write not to scale.
No, don't do that because they've just said to scale, right? So you can either say not to scale or you can
Ignore
have a
the
scale.
numbers.
Yeah, no, unfortunately you can't do that. So okay, you happy with that? Now, that was just the first one, so the next will proceed rather more quickly, okay? Here, I have what kind of shift?
Up.
It's a vertical shift and it's going up, isn't it? So, being that my vertical asymptote is here, if I shift that vertical asymptote up, it's just going to stay where it is, right? So, that feature is still the same, x equals 0. Okay? Oh, I should have put this equation in, by the way, but you get the idea. Okay? So, my asymptote's in the same spot, okay? But having moved up, right, you can imagine as I move this up, the x-intercept is going to move in closer towards the y-axis, right? How much closer is it going to move? Well, how do we usually work out x-intercepts? What do we usually do that? We let y equal to 0, right? So if I do that in this case, let me just grab another color. You can see it's not that hard to work this out. If y is equal to 0, then log base 2 of x equals minus 1. I just kick that 1 over the other side, right? So now when you convert this back into an index equation, where did I get it from? This becomes 0 and that 1 will go over. Okay? So this really means x is to the minus 1, which is a half, right? So actually, as I draw my graph again, right, that's going to be a half now. That's a half. So I'm nestled in closer. I need a point for scale. What would you suggest?
1.
If I put in, now, careful, because if that's a half, then 1 must be exactly twice as far away from the axis. What is going to be the corresponding value?
1. 1. Yes, it's 1.
I'll say log base 2 of 1. So what power do I have to raise 2 to get 1? And the answer is 0. 0 plus 1. So this is going to map across to 1. Okay? You happy with that? And let's put our equation on there, and then we can go. Okay? Excellent.